Okay, so basically, this is day 4 of our SolidWorks 1 week bootcamp, and today, that is on day 4, we'll be exploring part modeling further because there were so many tools that is still pending and we have to learn. And it was because of the time constraint, it was not possible to cover all the tools on the day 3. So the tools that are left yesterday, we are going to cover today. And also, we'll be doing some little bit of design practice. So you can have your questions ready about the process. So let's dive into SolidWorks and we'll start exploring rest of the things. And before I will start, if you have any questions, you can ask, you can raise your hands, you can write it that into the chat box as well. So if you have any questions, if you don't have any questions, just write N into the chat box. And I hope all you also can find the recording into the dashboard because I had seen you have already submitted the assignment. This means you can access your dashboard. You can see the recordings also. So the day 3 recording is already live onto the dashboard. So each day I try my best to upload the recordings as soon we finish the session. So it takes me some little bit of time to remove some of the silent content into the video. Okay. Okay. So how to make hash type of pattern? That is what you are asking. So let me open the assignment and we'll see what exact problem you were facing. So I will just open it, and now we are into this. So you're talking about day 3 assignment. So we'll go to the day 3 assignment, and you are okay. So in day 3 assignment, you are talking about this part, right? This hatch part, how you can make it, right? Is that okay? So let's practice this same part today. So we'll have the complete idea. So we'll practice this same part today and we'll see how we can make it, right? So we'll have a complete idea. Okay. Okay, so let's do this same model into SolidWorks and then you will have an idea. So we'll keep this model onto the side of my screen so I can see all the dimensions and details, but you cannot see it since you already have this designer drawing. You can open this into your computer or PC, right? So now I have opened that. Let's move and deep dive into the SolidWorks. And all the time again repeating, if you have anything not clear, so you can stop me, you can ask your question, right? So now the first thing, as always, we will launch simply a single empty part file, and that we can same way we can do through file menu. But today I will use the keyboard shortcut, that is Control+N. So I will simply press Control+N and this window will pop up. We'll select the part, we'll press OK. And the moment we'll press OK, it will launch the new part file. And the first task, as we always do, is to save the file. And to save it, we'll simply go on to, again, we'll use the keyboard shortcut. We are not going to use any of these tools. We'll simply use the keyboard shortcut. And that shortcut to save your file is Control key plus S key. You have to press them together. So Control plus S, and you can say it's saving. So it started saving. So let's write it day 4. Day 4, and we'll save that into our desktop. I will click on save. And the moment I clicked on save, you can see the file name just got updated. Also the browser tree top over here, the name also just got updated. That is day 4 here and here as well. So that way you can verify. So that way you can verify whether you have renamed the file correctly or not. So I can see some of the people are joining wrong group, wrong meeting, because somehow because of little bit problem into my software, I have created multiple Zoom meetings, and I can see so many of people are joining over there. So just give me a second and let me write into the group so everyone can join into this group only. Okay, so I just updated that join into this meeting only, but I can see so many people are joining into some other meetings. I don't know what is that meeting, but I'm receiving that notification that, okay, so 3D tools and feature. That is, I think, for the day 3. Someone has logged in and joined into the day 3 session anyway. Anyway, we'll continue our learning because we are into the right classroom. So right now, as you can see, we just started the drawing. Now the next thing, we'll make sure that the units, the system of units that we are following is correct. So we'll go to the bottom, right bottom corner, and we'll make sure that the system of unit, that is millimeter gram second, is correct, right? That's completely correct. We're not going to change any of this thing. We'll simply keep it, right? Now the next task. The next task is we'll start with a sketch, right? And to get that shape, we always have to start with a sketch. So we'll go on to the sketch. We'll activate this sketch tool. We'll select any of these 3 planes. This time I will select, let's say, front plane as a sketch plane, or we can also select the right plane, right? So it's completely on to us. Let's select the right plane so we can start our sketch. I will simply click on it. And the moment I will click on it, all my sketching tools just got active. Also origin is visible, so I can start creating our first sketch. And that sketch, I'm going to use the same drawing that you have seen over here, the shape like this. Since I am on the right view, I will try to get this kind of shape, right? And to get this kind of shape, let's see how we can do it. So we'll place it onto the side so I can see it, but you cannot see it anyway. So I will place it onto the side. I will start with this line tool. I will activate the line tool and let's start creating. So I will start from the origin, something that will go straight like this. Then something, I will zoom out a little bit. Then something that will go straight like this. Then a shape like this from here to here to here like this. Then little bit towards top. Then something like this, 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 and this. So you can see what I did. I have simply created a similar shape, right? So we don't have any control onto the dimension of this complete shape, but somehow we created this shape. That is just not exact shape of that design, but just a rough picture using the simple line tool. So once the line tool was active, I can keep creating the continuous lines, right? And I simply created this line. Now if you'll notice, into your sketch, into the details that we have provided, right? So we have to make sure that we know all the dimensions, right? So even if we don't know any of the dimensions, we can estimate that, we can take it anything, right? So let's first enter the value and give this dimension. So let's make this one as 20, right? Now this is 20, so let's make it this one 25. Here you can see. Also, let's make it from here to here, this one also 20, right? Like this. Here you can see, very simple. Now I will again activate the sketch dimension tool. I will make this one 65. So you have to input the values like this, right? Again, let's dimension this one also 20, right? Very simple, very easy. Now again, activate the sketch dimension tool and let's make this bottom as, not this one, let's make this bottom line as 15, right? This one we just made it little bit smaller. Now let's make from here to here, we want to keep this dimension, let's say 50, or yes, 50 is good. We are not going to change that. And we want this to be smaller, so we can drag it, right? We can make it smaller. Also, we can drag this line little bit like this, and we'll also drag this and reduce the angle. And since we know the angle, we can simply activate the smart dimension tool and we can dimension the angle between these two lines, and let's make it 105, right? Like that. Now we also want to add this dimension, this one, so let's make it 25. So you can see how easily I am making the dimension, still the drawings are not defined, still there are so many blue areas, right? So no problem, we'll check out which dimension we have to provide. So you can say, see, it's moving, right? And it's moving because this side is not defined. So we'll activate this dimension and we'll provide 25 or maybe 20, I think is good. Here you can see. Now again, this one is still will able to move. So we also have to define this one, right? So what I will do, I will activate my smart dimension tool and it will define this one as 50. So here you can see it got adjusted, right? So that way we can provide dimension. Now this line we have to define its position. Right now it is not defined. So I will activate the smart dimension tool and will define this side. Let's make it 65. So here you can see what I did. I have defined all the dimensions very easily. Now, I think this is the sketch we needed here. But here is one more thing. Instead of 25, let's make it 30. So a little bit more space we are getting over here, right? Very simple. Now, since we got this shape, now the next task is to finish the sketch, right? I will simply click on finish the sketch. So what I did, I simply created simple sketch. I provided all the dimension until I got my sketch fully defined. That is color change from blue to black. Now is the time I can click on this finish sketch option, right? And the moment I will finish the sketch, here you can see this is the sketch we created, right? Once you are out of the sketchwork environment, you cannot see any dimensions, sketch dimensions basically. So here you can see this is the sketch, simple plain sketch we created. Now, since this sketch is already selected, we'll move on to the features panel, right? And we can activate this extrude tool. Now, by default, this profile is already selected. But here, there is a one thing. I want to extrude this profile by 40 millimeter. I want to give it a thickness of 40 millimeter. But I want this 40 to be applied symmetrically with respect to origin on both sides. So if I'll turn on the origin, here you can see if I'll turn on the origin, right now the origin is this one. And it is extruding only in single direction by 10 millimeter. And even if we'll enter the value 40 over here, you can see it's extruding in this direction only. But I want this extrusion to be symmetrically divided with respect to point. So 20 on this side and 20 on other side, right? And how we can do that? For that, we have to turn this option into the, when you are active inside this toolbox extrude, you have to turn this option that says direction 2. So turn the option direction 2. Now in this direction, let's make it 20 first. Here you can see the 20 extruded. Now to also 20 on the other side. So 20 again on this side. So now it is total 40. But it's being symmetrically distributed on both the sides of our origin, right? I can click on finish, and this is the shape we got. So we got a basic shape of our design right now. It's not the final thing. We still have to apply so many features onto this, right? And I know you have lots of questions as well. Anyway, so all your question and query will be solved, and when I will keep progressing into this design, when I will keep adding new features into this design. So just wait and watch. Just be a little bit patient, right? So now first we'll apply one chamfer onto this corner, right? Onto this top is this corner that you can see here. We'll apply a chamfer, and also we'll apply few chamfer onto this corner and this corner. So to apply a chamfer, what I will do, I will go on to this fillet tab, fillet tool under the features panel, go to this fillet, activate this chamfer tool. Then tool is active. I have to specify the edge along which I want to apply chamfer. So I will select this edge, right? And you can see it's automatically applying chamfer of 10 millimeter and it's giving me the preview as well, right? So let's keep it 10 is good, I think. So I can click on finish. So you can see what I did. I applied chamfer onto this face. Now before moving forward, let's also apply some fillets, right? So the chamfer has been applied onto the top. We can also apply chamfer onto these corners, I told you. So we'll repeat the same tool. And this time I will select this corner and this corner. But this time I will not apply a chamfer of 10, only 5. So I will change the values. I can click on finish and you can see we just applied small chamfer onto this side as well, right? Here you can see. Now, no more chamfer. Let's apply some fillets because we have few sharp corners, these two sharp corners over here. And we also want to apply some fillets onto the internal corners. And for that, we'll simply activate the fillet tool from the same list. And first we'll select this bigger edge, right? And here we want to apply a fillet of, let's say, 15 millimeter. So we'll change the value to 15. We'll click on finish. And here you can see what we did. We have applied a fillet of 15 millimeter, right? Now let's again activate the tool, select this also and apply a fillet of 15. Again onto this face, click on finish. So that also, that sharp edge got removed. Now it is like a transition from a straight line to a arc, then again straight line. So that kind of curves look more consistent. Now is the time to apply fillet onto this edge and this edge. So let's first apply fillet onto this face, this edge, not this face, sorry, this edge. And here, instead of 15, I can simply apply fillet of 10 maybe. I think 10 will work better. And then you can click on finish. So here you can see this is what we got. Now let's also apply fillet onto the top, but on the top, I don't want to apply that much big fillet. I just want it to be 5. So I will change this to 5, click on finish, and here you can see. So this is something the shape we got, right? Now, if you'll go back into the design that you are following right now, so you will notice that we also have chamfers onto the edges of the design, right? And to make those chamfers, what we have to do, activate your chamfer tool again, select these corners, right? I will select the corner one by one, and here you can see it's applying the chamfer continuously. We'll do the same onto this side. And here you can see it's applying the chamfer. So this is what we needed. But here, instead of 5, we just want to apply chamfer of 2. So I will change that to 2, not 5. Just a small chamfer, that is 2. Here you can see the result if we'll apply the chamfer, right? I will click on finish. So you can notice how this shape just got improved the moment we applied this 2 mm chamfer onto these corners. Let's apply the same chamfer onto these internal corners and onto these edges as well. So let's activate the chamfer again. This time select this complete edge loop, also this complete edge loop, and also this front sides we want to apply. We don't want to leave anything, so we have to carefully select all the edges, and we forgot these also, so we'll add these as well. Here you can see. So this is how the chamfer is getting applied. Now on this edge and this edge I also want to apply, and onto this edge and this edge also. For these edges, I'm not going to apply any chamfer. I will keep it unchamfered at this moment. So don't apply any chamfer onto these edges. And we'll apply a chamfer of 2 millimeter. I will click on finish. So here you can see this is the shape we got. Now, if you'll notice, if you'll go into the assignment, you can see onto the design, we have these cutouts. Can you see these cutouts that is going up to this face, right? So we have to make that cutout first, right? How we can do that? Very simple. If you remember, we have to start a sketch onto this face, right? And to start a sketch onto this face, the same process, go to the sketch environment, activate your create a sketch tool, and then select the flat plane where you want to create a sketch. Click on the plane. Now let's add, using the line tool, I will create a shape like this, and same over here like this. Now here is one thing. I want all these 4 sides to be equal. So I will press shift on my keyboard, will select all these 4 lines and will apply this equal constraint. Now click on finish. So all 4 lines just became equal in size. I will also make sure that this point and this point are horizontally aligned with respect to each other. So how we can do that? Simply select the line by pressing shift on the keyboard and apply this horizontal relation between these 2 points and click on finish. And what is the benefit of it? So we'll try to move these one little bit towards upward. You can see the other is also moving. Why? Because they are now in a relation of horizontal label, right? So we'll do the same for these points as well. So we'll activate, again we'll press shift and we'll select both the points and we'll apply the horizontal constraint. So the moment we did until this point, now this will be automatically constrained, right? Here you can see. Now the next thing is to put some dimension from this side to this side. The depth I just want to keep 5, so I will enter the value 5. Also from the top of this line to the start of this line, I want to take 5, so I will change this number to 5. Also the width of this one I just want to keep 10, so I can enter the value 10. And now you can see this just got fully defined, right? And if we'll go back to the face again, we also need a cutout onto the top, so we can again activate the line tool and we can create a shape like this. But this time I want this to be aligned with respect to the origin, vertically aligned. So we'll apply the vertical relation this time like this. I want all these, also I want all the 3 edges to be equal to this edge. So I will select all the 3 edges by pressing shift on our keyboard. So all 3 lines are selected and we'll apply a relation that is equal. We'll click on finish. Now we can also define these things, like this one I want to keep 10, and that's it. Our sketch got fully defined. I can click on finish the sketch. So this is the sketch we created. Now what we'll do, we'll simply go to the features tab, and since we want to make a cutout using these profiles, I will activate this extrude cutout tool. Instead of using extrude boss, I will activate this extrude cutout tool, right? And the moment I activate it, I will go on to the contours. I will delete this first by pressing delete on our keyboard by selecting that. And then I can come on to our face and I can click inside the profiles to select it. But you can notice there is some very weird behavior, right? You can see even if it's selected the profile, it is making something very wrong. What is the problem? The problem is here by default, can you see this thin feature option is turned on? So you have to turn that off. And the moment you will turn that off, you can see it started making cut. But still, it is not cutting through until this face. What it is doing, it is cutting only up to the 20 millimeter distance. So to make sure that it is cutting up to this face, we'll change the direction to, okay, so we'll change the direction to through all both. No. Through all? No. Okay, so we'll change the direction to, we'll activate this option and we'll select this face. Okay, so it's not making a cut. Anyway, so what we can do, instead of going that way, we can also define the values. So let's make it 50. So the moment we entered the value 50, you can see it's making a cut, but we want to reach up to this face. So that is, I think, around 70. And if we are going 70, we are going a little bit higher. So maybe we have to adjust a little bit. Maybe 65 will be the right distance. Yes, 65 is exactly the right distance. Yes, correct, Sachin. It is exactly the right distance. That is 65. Now I will simply click on finish and we made a cut like this. Can you see that? Exactly like our design. Maybe few dimensions will be different, but you can consider the right dimensions if you have the values. Now we also want these edges to be filleted, right? So we'll again not filleted, sorry, chamfered. So we'll again activate this chamfer tool, and this time I will select this face, but chamfer distance I just want to keep 1, very small. I will click on finish. So if you want to select all the edges, you just need to select the face to chamfer. You don't need to select each edges individually, right? So that way you can save some time. Now this is what we created. Now the basic shape of our design is almost complete. The only thing left is to create hole, right? And if you remember, I already explained you how to create holes. So simply activate the hole wizard tool, right? Very easy. Then define this one, simple hole. Then go to the position and click on that flat face where you want to keep your or want to create your hole. So I will select that face. Then I will define the point where I want to create a hole, right? Then I will define the position of this point. So let's say I want this hole to be just 10 mm on this side, and I also want this hole and this origin to be vertically aligned, so it is just at the center of this complete body. I will click on finish. I will go back to the type. I will change the hole size to 10 millimeter, or maybe much higher, 16, or maybe more higher, 20. You can see like this. So let's say we keep 20, we'll click on finish, and you can see this is the hole we created, right? And we also need one more hole that is on this face, but this face already have very less flat space available. So we'll ignore that hole at this moment because the process will be almost the same and I don't want to waste your time. Okay. Now is the time to create a shape like this. If you can see on your screen, now is the time to create a shape like this, that you can see this hatch kind of shape, this slotted kind of shape into our design. And if you'll notice, the shape size of this shape is the gaps are, the depth are 1 millimeter, whereas these like extruded spaces are 1.5 millimeter, right? And also this depth is 2 millimeter. So we'll remember these values. We'll go back to our design. Now to get that shape, we have to create a sketch onto this face, right? Or this is the only way, we have to create a sketch, right? And then we can use the combine tool. So we'll see how we can do that. First, go to the sketch panel and click on this create a sketch tool, right? And then select this face. Now we are ready to create a sketch onto this face because we have selected this face as a flat face to start our sketch, right? Any questions up to this point, guys? Okay, who is Samsung? Can you please write your name? Who is Samsung SM M31 whatever? Please write your name. Okay, maybe he is not available. Anyway, okay, Biswajit. Okay, Biswajit. So I think you have joined through mobile today, right? I always recommend to join through the laptop so you can have bigger screen and oh, okay, no problem. Anyway, you can watch the recordings also. So what we did, we just activated this face as a sketch face. Now we'll go to our sketch tool, and here we are going to use that rectangle type, not center rectangle. We are going to use this rectangle that says 3-point corner rectangle, right? So first go normal to this face and let's activate this corner rectangle tool. And now create the first point, second point, and then a rectangle like this. So here you can see what we did. We created a random rectangle of some random size. Can you see that? We don't know the size of this rectangle. What we'll do before we'll move forward, we'll select this edge and also this small slanted edge. And the moment we selected these two edges, on the left, can you see there is a relation that says parallel? I just want to make these slots to be parallel with respect to these chamfers that we have applied. So we'll apply the parallel, and here you can see this just became parallel to this line, right? And we'll click on finish. I will extend this rectangle a little bit so it is covering the whole width of this. Also onto the top, we can adjust it until it is covering the whole width. And then I will activate the smart dimension tool, and from this edge to this side, let's keep it 2 millimeter like this, right? Now I have to adjust it little bit more so it is covering the whole length of this shape. So at the bottom it was okay, at the top we have to adjust. Now the thickness, if you'll remember, for this one was 1 millimeter, right? So we'll change that to 1 millimeter. Let's add from this, let's add some dimension to this rectangle. Let's make it 40, a little bit higher so we can have more space to play. Also add from here to here, let's add some distance. Let's make it 5. So it is almost above that face. So you can also make it 1 because we just want it to be cover that face. Not 1, let's make it 2 like that. Now what we'll do, there is 2 ways to get that slot cut, right? One way is to pattern this same sketch multiple number of times, or else you can come out of the sketch and then you can go to the features panel. You can extrude this profile just by 2 millimeter towards opposite direction. I mean towards inside the body as a new body. Just turn off this option that says merge result. And if you click finish, you can see we are getting a new body got added like this into the body. That is starting from this face and then 2 millimeter deep, right? Very simple. So this is what we did. Now what we'll do, since inside solid body we got this as a main body and this as a new body, right? So now we'll use this linear pattern tool, right? Even we have another tool. If we'll go and check, we have a tool called okay, let's use this linear pattern tool. And we have learned this tool inside sketch panel, but we have never learned this tool inside solid and features tool panel. So now we'll use this linear pattern tool. And to use this tool, what we'll do, we'll simply activate this linear pattern tool, right? And tool got activated, you can see on the onto the left side. Now first thing is the direction, like in which direction you want to make a pattern. So I will select this bottom edge as a direction, right? Then the distance, right? Like how much distance you want to cover your object. But before entering the distance, I will scroll at the bottom and I will activate this option bodies, because this is a separate body and this is the body that we want to pattern. So we have to activate this option bodies and then select that body, right? And the moment I selected that body, you can see the number here is 12. That's why it's patterning this same body towards this direction by 12 number of times. Also, the distance between each of them is 10. But if you notice from the drawing, the distance between each of them is just 2.5, right? So I will change this value to 2.5. 2.5. Here you can see, not 2.5. Or not number, sorry, distance, 2.5, right? And then the number I will change 12. So the numbers we have to keep, maybe we have to increase this value. It's not 2.5, I think it's 4.5, sorry. Yes, this is 4.5. And then the number is 12. And if we are keeping the number 12, you can see we are covering almost the end of the corner. And if we'll increase that number, you can see it's going outside the body. So that's not right. We just want to keep until the body. So we'll create like this. We'll click on finish. So what I did, we have patterned this object by 12 number of times towards this direction, towards the direction of this edge. And this is what we got, right? And they all of them are equally spaced, right? Just by 2 millimeter between them. So this is what we got. Now is the time to create cutouts like this. What is the tool that we have to use to make a subtraction like this from the body? Can you write the tool name? We have already explored in the last class. It's not extrude, it's not trim, it's combine tool. It's combine tool that we have to use over here, because we want to subtract all these 12 bodies from this main body, right? Then only we'll get that shape. So we'll activate this combine tool. We'll activate this subtract option. And then under the main body, I will define this big body. And then under the body to subtract, I have to select all these smaller bodies one by one. Whatever the number it is, I have to select all of them one by one, and you can see all of them just got selected. So if you click on show preview, you can see we are getting a shape like this. And if you click on finish, that just got applied and we got a shape like this. So you were talking about this shape, right? It was very easy. You just have to apply your simple common sense, like how we can get this shape. So I told you in the beginning when we are starting this session, designing is not about using tools, it's about your thought process. And it will only you can develop if you'll keep practicing, if you'll keep practicing different designs, different features. Because the same thing can be done in multiple ways. Either you do multiple sketches and make an extrude cut, that is also possible. Either you can create multiple bodies and use the combine tool, that is also possible. So to get the same shape, the approach can be different for different people, right? But you have to develop that habit, right? You have to develop that thought process, and that is the only way to get started into the design. And it was very simple. You had seen from your eyes, like it was very simple, it was very easy to do, right? Now this is the save we created, so we can save this design. And this was already into the assignment. I don't know if you know, if you have noticed or not, but this was already into the assignment. I just noticed that I've missed few of the dimensions while creating this drawing, but still you can reconsider or consider any hypothetical dimensions just to get the shape, because the overall task is to help you get this shape, that how you can design, what is the process. your dimensions are not really important, because this is not a real part. This is not a real engineering drawing or something. It is just a practice model. So you can consider if any dimensions are missing, like whatever works best for it, you can consider that. That's not a problem, but you have to get a shape like this. That is important. So right now you can see what we did. We had created the shape like this. Now let's learn the next tool inside this same feature panel. And the next tool is, if you want to apply a thread onto this hole or onto this cylindrical face, how you can do that, right? So for that, again, we have that same tool, that is hole wizard, but you have to expand that tool, and then you will find that tool that is known as threads. All of you can see this, right? Thread option. So what you have to do, once the tool is active, just activate this thread tool, and once the tool is active, you can see you will get a pop-up like this. Simply click OK, and on to the left side, tool is active. Now it is asking me, the first option that it is asking me to select the face, cylindrical face, where I want to apply thread, right? And into our design, this is the face. So I will click on that face. Not onto that face, I can click on the edge from where my thread will start. If your thread will start from that direction, you can select that edge. So here I will select this edge, and the moment I will select the edge, you can see it's giving me a small preview, but the thread here that we are creating is not covering the whole length. So I can change from blind. Let's keep this blind and increase this value to 20 or 25. Maybe 25 will cover the whole length of the thread, and even it is going a little bit higher from the thread hole, but that's not a problem. If it is crossing, this means we'll get a whole a threaded thing onto that side. Now if we'll come at the bottom, you can see we have different numbers over here, right? And these numbers are starting from M1. Here you can see these numbers are starting from where is the number? Yeah, it's starting from M2, M3, right? So it's starting from M2, M3, and so on, right? And from where we are getting these numbers like M1.2, M1.4, why it is like that? And the reason is, if you want to create thread on any of the body, you have to use a drill machine, right? There is no way to create threads like this. You have to use the drill machine or a thread tapping machine. There is no other way to create thread. And if you are using thread tapping machine, thread tapping machines always comes with tools that are standard in the industry. You cannot create your own thread tapping tools. There is always a standard tools that is being used by across all the industries. Same tools with the same sizes are being used across all the industries, and all these size options are available over here, right? For example, let's say if we want to use M10, right? So I will select M10, and the moment I will select M10, you can see the thread is adjusting according to the size I have selected. Or let's say if you want to use something else, let's take M12. So if I'll select M12, you can see the thread size is adjusting according to that. So it's completely on to us, like which kind of thread size we want to use. And right now this is cut thread. So if we'll click on finish, it will create a thread like this onto the hole. Can you see that the actual thread we created inside our body like this? And since the hole was almost touching, so that's why, because we have extruded this thread little bit extra from the body width. So we can control that using the thread length that we have considered. So instead of 25, let's make it 20 only, right? 20 only. And now click on finish, and it will not extrude more than that. Here you can see like this, right? So this is how you can create threads inside your body in SolidWorks, right? It's a very simple tool, but standardized according to the thread tools available in the market, right? Okay, let me take few questions. I can see this is saying, I was unable to attend previous 2 sessions due to personal medical emergency. Yes, you can get the certification, but I will recommend to at least go and practice or go and watch the old recorded session. So we'll have the idea, because getting a certification is not an end goal for us. Learning something from these sessions are important. So just go and check out the learning sessions, and definitely you all will be getting certificate. Don't worry. Okay, so Viswajit is saying, is this through hole can apply? Uh, See, the moment we are into the thread tool, right? The moment we are into the thread tool, and here we are not getting an option to apply through hole, right? You can only control the revolution of your thread, or up to the selection you can apply. So if you'll activate this up to selection, then I can select this face and it will only apply thread up to that face. So up to is possible, but through hole is not possible. So see what I did, I had applied thread up to this face only. So that is possible. Standardized for bolt. Yes, yes, it as per bolt, and whatever the we already have the union for mechanical engineers, that is known as ASME, right? American Society of Mechanical Engineers, and they used to decide these standard sizes, right? From ASME, they decide all what are the thread sizes that all the world will be follow, because whatever the parts we are creating, that should be compatible with other country products also, and that's why they have created this standard that is acceptable by all the countries, and especially the threads, hole sizes, and the stuff like that. If you are creating something custom, maybe in other places it will be hard to find fasteners for that. That's why the standardization is important for any product. That's why if you see your mobile phone, the type C charging port is getting standardized along all the mobile phone industry. So none of the companies are now using different kind of charging cables, and so each chargers will be compatible to each phone very easily. And very soon they will also be standardizing the charging, like watt power of our adapters, because of that we are generating lots of e-based, right? Because your old chargers are not compatible with your new phone, and because of that we are generating lots of e-waste. So definitely the government will do something anyway. So this is the save we created, right? And we have learned one more tool today, and that was to add threads into our body. Now there is one more thing that I want to explain over here. Let's say, let's add a small hole. I will activate this hole tool again, right? I will go to the position, will select this face, and here I will add a small hole. But I don't want to create this hole through hole. So I will go on to the type. I will change to blind, and I just want it to be 5 millimeter. Like I want to be very small hole, kind of depth kind of cut. Can you see that? Like a hole like this. Now let's say you have created this hole, right? And now you want this same hole also onto this other side, like mirror of this hole. So like we did in 2D sketching environment, we also have a command that is known as mirror tool, mirror features inside solid feature panel. So activate this tool mirror, and when the tool is active, the first thing it is asking you to select the mirror plane, right? So mirror plane is nothing the mirror, which will be acting as a mirror. So in our case, if we'll expand the design tree, since our body is symmetric with respect to this right plane, right? So if we'll see, if this is the right plane, right? And our body is symmetrical, so we can select this right plane as a mirror plane, right? So I clicked on the right plane and that just got selected. Now, in the next step, it is asking me to select the secondary mirror face. We don't have any secondary mirror face, so just ignore this option. Now, the next option is that what feature you want to mirror, right? So this is the feature, this hole that we created over here. This is the feature that we want to mirror onto the other side. So I will simply click on this feature, and that feature just got selected. And the moment I will select it, you can see the preview, right? You can see the preview. It is right. I will click on the finish, and you can see that same feature just got mirrored onto the other side also. Just within seconds, I was able to replicate any feature onto our design tree on the other side if my body is symmetrical, right? That's why I kept it symmetric in the beginning. When I was applying this boss extrude, I extruded it in both the direction with respect to the origin. Because if you'll keep your body symmetric with respect to the origin, there are lots of things lots of stuff that you can control during your design process, right? So don't worry about that. Always keep your design, and this kind of thought process only come when you will keep practicing. I'm again repeating, just keep practicing. Okay, so this was about this mirror tool. Now, since we are done, right, what we can do, we can simply click on the save again. So our drawing will be getting saved. Now, so we have already explored many of the tool. Now let's learn about few tools that is important here in this case. And that tool is if we'll go to the evaluate panel, right? If we'll go to the evaluate tool panel, can you see there is a tool known as measure? For example, you are not inside sketch and if you want to measure this edge, right? So if you select this edge, you will get the value 15. So this is length is 15, right? Now, if we'll see in this direction, let's select this edge. This edge is 14.14. So that way we can measure any of the edges. But what if we want distance between this face and this face, right? There is no edge we can select that is connecting these two faces. If we select this edge is starting from this point and ending at this point, right? But we want distance from this face to this face. Since we already know the distance, but don't worry, still if you don't know the distance, how you can do that, how you can find it, then you have to come on to this evaluate tool panel, and from the name itself explain these all the tools available over here are to evaluate your designs, how you can check something, how you can evaluate it, and related to those operations you will find all the tools over here. So if you click on this measure tool, this tool will help you measure any of your side features or design things. So I will activate this uh, measure tool, and then we'll select this face first, and then we'll select the next face first. And the moment we selected both the faces, it is highlighting a distance between the faces that is 40 millimeter, right? That way you can measure the distances. For example, let's activate it again, and we'll select this and this, and here you can see we got a distance of 85 millimeter overall length of our body. So this tool is very important. I can see Sachin is asking if it's not symmetric, how we can do that. So that's not a problem. If you want to mirror anything and if your body is not symmetric, then definitely you need some plane at the midpoint of this body, right? So you can use it as a mirror plane. So for that, you can use this construction tool, reference plane, activate it, and then select the faces. And you just have to select multiple faces, and it will automatically create a mid plane between those faces. And then you can click on finish, and the moment you will click on finish, you will get a plane 2 that is just at the mid plane passing through the origin, right? So you have to create a reference plane first, and then you can use that plane as a mirror plane, and you can start mirroring your objects. That is the way, right? I will turn that plane off at this moment. Now, I was talking about this evaluate panel. So the first tool was this measure. Then I'm only going to tell you the important tools that is available over here. So the first is measure tool. Next is the mass properties. And to calculate the mass property of this solid body, what is the mass of this body? We have to define the material first, because right now, if we'll go into over here, and you can see in the design tree, we also have a materials section, right? But under the material section, there is nothing specified at this moment. So I can make a right click onto the materials. I can click on edit materials, right? Now I have a list of predefined materials from SolidWorks. So these are mostly all the materials that are available inside this SolidWorks materials. But if you want to create custom one, you can do that. But let's say I want to use steel. So almost all the materials are available. You don't have to create any random or any custom material. So let's select this 304 steel, right? And 304 steel is one of the most commonly used steel types into the industry. So I will select 304 steel, and once you will select the steel, you will get all the material properties over here, right? So these are all standard material properties for 304 still in AISI standard. So you can cross check with your material certificate that you are getting from your vendor if these values are right or not. So in most of the cases, this will be right, because again, materials are also very standardized across different countries, right? These values are almost the same for different countries. So let's say I will select this AISI 304 and will click on apply and we'll click on close. So what I did, I had applied this AISI 304 material to this body. Now, if I'll click on mass properties, for this day 4 part, you can see we got full details of values over here. So we have selected the material as AISI 304, and for that we are getting a mass of around 1.393 kilogram or 1393 gram. Here you can see. You can also calculate the volume of this body, that is 17 not 1,74,000 and something cubic meter, right? So we can also calculate the volume of our object. We can also calculate the overall surface area of our object. We also got the center of mass detail. We also got some inertia details and all the stuffs we have available over here. Like if you want to share with someone, you can simply click on this print option and then you can print this complete properties panel and you can save it with someone. But and if you are anytime, for example, if you will see the mass properties right now, the mass is 1393, right? And if we'll change the material and we'll see what difference we are making. So let's change it from steel to plastic, right? Let's make a ABS plastic. We'll apply close. Now definitely the mass will update. So we'll go on to the mass properties and we'll see now the mass became now the mass became very lighter. Now it is only 177 gram. Earlier it was 1393. Now it is 177 only. So you can see the values are updating instantly the moment you are updating your materials for your parts. So very easy, right? Any questions up to this point? Okay, so you are using AISI 14130. So for the materials you can explore, like we have lots of materials available. Even you can configure the existing materials. Like right now we are using ABS, so I can configure this ABS material all the time. We have that option. So you just have to explore like how you can do the configuration and all those things. Even if you want to remove the materials, you have the option to remove, right? So few common materials are already into this shortcut list, but again you can control the things. You have the full option. Now this was about this mass properties, using this mass properties tool. Right now there is one more tool that is important over here, but that will be learning into the next session when we'll start doing some assembly, when we'll start working with some multi-body multi-part assembly projects. So in that case we can learn about the other tools, but let's ignore at this moment anything. These were the only two tools that were important into this space, right? Especially for the beginners when you are just getting started. Now once you are done, you can click on the save, and let's say you want to export this file as a common 3D file format, that is step file format. How you can do that? Very easy. Go on to this save as new option. Like you can click on this save as new option, and then you can export your file into these all types of file formats. So if you want to export this for some other software, let's say you want to export it as a DXF file format or DWG file format, you can select that file format and then you can save it as a DWG file. Or if you want to save it as a step file, you can select step. So we have lots of varieties available if you want to export your design into different file formats. I'm not going to save it, I'm not going to export it, so it's completely onto you. Even if you can export this as a STL file format for 3D printing. So we have all that options available over here. When you will activate this option, save as new, you will get all those options, right? You will get all those options, just it's a click away from you, right? So these were all the most important parts And apart from this, there is one more thing, one last thing that I want to share with you for today's session is for this material, you can see the moment we applied the ABS material, the color got updated, the appearance got updated for this body. I want the same material ABS, but I want to see it in a white color or black color. How we can do that? For that, you just have to move on to this option that says display manager, right? Go on to this option that says display manager, right? And by default, you can see this is the applied material type onto your body. So if you make a right click on it, you can click on edit appearance, right? And the moment you will click on edit appearance, you can see a window will pop up like this onto the right side. From there, you can select different kind of appearances available into this SolidWorks library. So let's say I want to apply, the material will be plastic, but I want to look it like a fabric. So I can check inside the fabric if we have some material options available. Yes, let's take this blue one, simply drag it and place it onto the body. That's it. And you can see for day 4, what material properties, what material appearance we have applied, fabric blue. I will click on finish, and you can see if we'll come back to the part file, the material is still ABS. And if we'll check the mask properties, the mask properties are also the same. What happened? Only the color of the object just got updated, right? And now it's looking like a blue fabric. If you can see it carefully, you can see, if you'll zoom in, you can see it's looking like a blue fabric, but still the material is same. So you can control the appearance of your body also. It will not affect the material properties. So material properties will only change if you'll make it and change the material type from this list. Otherwise, the appearance, you have the full control to change any kind of appearance, whether you can make it kind of a stone kind of look. So even if we want to look like a stone, we can make it look like a stone, right? We have also have an option to make it look like a metal. So we'll go back to the metal section, and let's say I want to make it chromium plate finish or the stuff like that. You can say it looks like a chromium kind of stuff. So we have the full control. So this was all about the today's session. We have practiced and we have learned few more tools. Now let me know if you have any questions. The question and answer session is now open. Okay, so your question is, what is the purpose of secondary mirror face, right? See, secondary mirror face basically work in multi-body concept. I cannot explain you in a single body concept when there is multiple body in a assembly, or if you are doing assemblies where you have multiple parts. In that case, I can explain you. So don't worry, I will explain you in the next session where we are going to talk about all the assemblies. I will note it down this question and we'll discussing that. What is the use of secondary mirror face? Okay. Next question. So the people who don't have any question, just write N into the chat box. And if you have the question, just write a question. Block table, that will be learning in the last session, not last session, second last session. So this is 4th session. 5th session will be about assembly, and 6th session it will be about drawings, right? How we can start generating drawings from our parts or assemblies. So in that session, we'll be learning about how we can insert title blocks, how we can edit title blocks, and how we can edit informations inside title blocks and the stuff like that into the 6th session only. So don't worry about that. Day 3 recording is already being uploaded and is live onto the dashboard. So okay, so I forgot to post the link for the video into the group, right? I will do it, don't worry. But the onto the dashboard, that recording is already available. So if you don't have any questions, just write N into the chat box so I can have an idea, like those people who don't have any question, we can finish for them. Just write N into the chat box if you don't have any questions. Sachin, don't have any questions. Biswajit, which practice time is very less? There is no deadline to submit the assignment. Deadlines are completely like, it's optional. There is no need to submit. Even if you can submit after these sessions are finished, like, so you have the full time to submit the assignment. Don't take a load. It will not affect your certifications. Assignments are completely optional. Biswajit is saying daily class. That's why I know that it's It's a continuous class. So don't worry. We'll be keeping a small break tomorrow. So we'll not have a class tomorrow. So you'll get a chance to practice these 4 sessions that we have already finished. So I will update you. I will send you a message. We don't have any classes tomorrow. So you want to make a damper, right? Okay. So if you want to make a damper, you can share some sample images or reference images into the group. So I can utilize that and will show you how we can make a damper. Fourth is today, I think. The fourth session is today. Tomorrow is the 5th session. That will be a break. So 5th session will be on 4th of September. Okay. Okay, guys. Thank you so much for learning, for coming and learning with me. I hope you are practicing. I hope you are learning something new to your career, to your class, into this class. And please keep learning, keep growing. We'll see you in the next session. We'll see you in the not tomorrow, day after tomorrow. So keep learning, guys, keep growing. Thank you. Bye. Good night, everyone.